Good afternoon, everyone. We're ready to start. Would you please take a seat? Do you want me to call names? I want to say thank you all for coming and welcome to this welcome session. Welcome to the HI-TEC conference and welcome to Florida, those of you who are from elsewhere. It's my pleasure to host this event this afternoon, and the short agenda is we will have a panel discussion for about 45 minutes, and then at 5:30 or whenever they get done, we have some food in the back that will be available at that time. And also there's a bar, and the college displays are around the room from the colleges in Florida that are attending the conference tonight or this week. So please visit those tables and talk to those people, and the panelists will also be around to ask questions to or talk with as well. So I'm not going to say any more, but introduce Michael Witt. Dr. Witt is the Dean of Engineering at Miami-Dade College, and that's in Miami. And he's going to introduce his panel, his industry panel, and take it over from here. So again, welcome, and thank you, Michael, for emceeing this panel.
Okay, thank you very much, Marilyn. Good afternoon, everybody. We can try that. Let's hear a little bit. We haven't started to drink yet, I hope. Good afternoon, everybody. It's my pleasure to be here and moderating this panel today. I think that we have a great opportunity as people with technical backgrounds, and specifically people in engineering technology, to really make a difference with a lot of things that are going on right now. And I'd like for us to be able to explore that during this hour that we're discussing. And we have some panelists, and I'm very grateful that they've taken the time to be with us today to help us explore some of these solutions. And as I introduce them, I would like for them to come up one at a time. The first panelist is Jaime Boras. Jaime Boras has founded 2 technology startups and is currently COO of Generation 1, a wireless mobile health monitoring solutions company. While at Motorola, he served as Senior Fellow, Corporate Vice President, and Chief Technology Officer of IDEN Mobile Devices. Mr. Boras has 42 U.S. utility patents, is chairperson of the Florida Atlantic University Industrial Advisory Board, and is a member of the Florida International University Industrial Advisory Board. He was also elected president of the Latino Business Council. Mr. Boras has been recognized as one of the top 50 most important Hispanics in business and technology. He holds a Bachelor in Science in Physics and Electrical Engineering, a Master's in Electrical Engineering from Florida Atlantic University. And additionally, he serves on the Industrial Advisory Board of Miami-Dade College, which is where I've met him. So I'm grateful that he's here with us today. I think I need to move this up a little bit here, don't I? The second person we have is Mr. Jerry Haverin. He is the chairman of the board, co-founder and president of NDH Medical Incorporated, a medical device contract manufacturer located in St. Pete, Florida. Mr. Haverin is the current chairman of the Florida Medical Manufacturers Consortium. He is a member of the Association for the Advancement of Medical Instrumentation and was issued 2 patents in the medical device field. He also serves on the advisory board for the Medical Device Industry Education Council, is a member of the Florida HI-TEC Corridor Council, and is in the Pinellas County Economic Development Council. He has a Bachelor of Science in Chemistry from Case Western Reserve University and an MBA from Baldwin Wallace. So welcome, Mr. Haverin. Thank you for coming as well. The third member that we have is Janan Balaban. She is the Associate Director of Industrial Collaboration and Commercialization. She has a master's degree in chemical engineering and has served for over 25 years in industry as a research scientist, engineer, and manager. Her industrial experience includes rechargeable batteries, biomass, coal desulfurization, gasification, sol gel technology, and sintering. She has transferred a number of technologies from research to manufacturing and has 2 patents and 1 trademark. Ms. Balaban joined the University of Florida in 2003 and has managed the $10 million NASA-funded hydrogen research program until the end of the grant in March 2008. During this period, she has facilitated the establishment of the Energy Technology Incubator and the Florida Institute of Sustainable Energy at the University of Florida. She served as the Associate Director of the Florida Institute for Sustainable Energy until she joined the consortium in January 2009. So welcome to Jana Balaban as well. Thank you for coming. Last but not least, we have Mr. Eli Torres. He is the Technical Support Manager for the Commercial Systems Group at Rockwell Collins, where his main focus is lab engineering support to aid in development projects from satellite navigation to airborne communications. Prior to Rockwell, Mr. Torres worked on the design of large-scale data routers at Lucent Technologies. He has a systems engineering degree and an MBA. So thank you for being with us as well, Mr. Torres. So please give the panel a round of applause. So what I'd like to do is to start this discussion on how we can have a significant effect as engineering technologists is talk a little bit about the title of our program today, Industry and Education. How are we going to find the solutions to the problems that we have, industry and education? And to start out with this, what I'd like to do is use a phrase that my mother has told me since I was yay high. And it has the word success in it. And it's how my mother always defined the word success. And I think it's appropriate here. She always says that success is where opportunity meets preparation. So you probably have heard that before. And really and truly, that's what we're trying to figure out in today's day and age, and how to use our skill sets as engineering technology people to make that happen. So clearly we have some opportunities, right? Right now, one of the things that we've seen from an unemployment standpoint from Bureau of Labor Statistics here in the state of Florida, I believe last month was 11.4% unemployment, and nationally double digits. So clearly with some of the metrics, we have some great opportunities. So what I'd like to do today is discuss with our panel how we can merge those two things that we have great opportunities with industry and education, and try to find some of the solutions to educational problems as well as economic problems that we have. So that being the case, what I'd like to do is start our discussion and show a few slides and then ask the panel some questions, and then leave some time at the end for questions from everyone in the audience. But basically what we have here is a few different sections we want to discuss today. I'd like to discuss productivity, gross domestic product, which is an economic indicator. I'd also like to discuss STEM education, which all of us in this room are involved in. And thirdly, how does product development fit into the current situation that we have as engineering technology people? So how does that work? Well, first of all, let's take a look at, this is a little bit of an older slide, but what you see here is you see the percentage of jobs that are in the manufacturing sector. And on this slide, you see the United States and you see other countries as well. One of the things that you notice is everybody's decreasing during a period of time. So the percentage of jobs in the manufacturing sector are less. Is that a bad thing? Is that a good thing? We'll discuss that. But it has been decreasing, and there are not as many jobs in that sector, at least the percentage of jobs in that sector, as a result of some of the things that have changed productivity-wise. Now, what has changed productivity-wise? What this slide shows is actually productivity from 1980 to 2000 for a host of different countries, the United States being one of those countries. And what you'll see here is, you can't really tell, but what you see here is on the far left side, you see the United States 2000 and the United States 1980. And you see other countries as well. You see India, you see China. And what we see is productivity between 1980 and 2000, we see an increase for every country. But what we notice is that other countries, the percentage of increase as far as the rate is faster in other countries than the United States. So that's one of the things I want to discuss today as well when we talk about the percentage of jobs that have decreased in the manufacturing sector. Thirdly, global productivity. We look at global productivity, we look at the population and our share in global productivity throughout the nation. And we see that as far as the share of global population, looking at it just from a perspective of the United States, we have 5% of the world's global population. However, we have a significant larger share of productivity globally. And so that's a metric that I think is important for us to be able to be aware of, and how we shift things from that, and also have an effect on other countries' global productivity as well. So ideally, do we want to try to increase the global productivity in other countries as well, so everybody's productivity goes up? So I'd like to talk about that as well. So with that being said, I have an opening question that I'd like to present to the panel. And everybody here represents a different sector. So whoever would like to take this question first? In your sector or organization, is product development important? And how do we improve and help others understand the importance of productivity?
If I can take 1 minute, I'd like to introduce our consortium. Our consortium, Florida Energy System Consortium, it was established in the year 2008 by legislature. Legislature provided us a $40 million funding. And the consortium brings all the state universities under one umbrella. We have 11 state universities, and the goal is to perform renewable energy related research and also transfer this technology eventually to industry, attract industry to our state for economic development. And we have 62 consortium-funded research, and some of this research is in collaboration with industry. So that part of research, which is applied research, it goes under product development. And so it is very important for our sector, of course, product development, coming up with new products, and also improving existing products, and to make the processes cost effective, to improve the efficiency, to increase the capacity. And so we are also, as a consortium, looking at process intensification and system level products. One example, for example, is that combining solar photovoltaics with batteries and also LED. So what happens with this product when it's developed, that it will collect the solar energy during daytime, it will store that energy with the battery, and then at night time, then you have through the LED, you have light. And this can be utilized all over the world, especially third world countries where they don't have electricity. They can tremendously benefit from this product. And this is just one example. We have a number of technologies in the product development area. So the other part of the question is that how can we improve this? And one way is to publicize the needs of energy within our state, within the US, and within the world. And so if you look at the breakdown of energy use within our state and within the US, is that we are dependent on other countries in fossil fuels, like especially petroleum and natural gas. And for example, we produce 10 quadrillion BTU of petroleum, however, we buy 37 quadrillion BTU, so there's a big gap. And we have a lot of coal, but with the coal, there's greenhouse gas emission issues. So with the renewable energy, however, we produce 7 quadrillion BTU and we use it all. Nuclear is the same way, we produce and we use it all. So if you don't want to be dependent on fossil fuels or petroleum in other countries, then we can put more emphasis on renewable energy because we have the resources. We have the solar resources, we have biomass. In Florida, we have ocean. We are surrounded tree-sized by oceans. We have all the natural resources. We just have to put the emphasis in that, so that we need to actually talk about it more, to publicize it more, and to get the attention of our state. And we are lucky that our state actually showed interest in this, and they invested $40 million in energy research. And then it is also important to share the success of the energy technologies, so that we can get the right policies in place, and we can get the attention of legislators with these success stories, and we can also attract investors to our state. I hope I did not take too much.
Oh no, thank you for that answer. I think Mr. Morris, you have a response to as well.
I think I'm on. Okay, so I guess I'll hit the answers to the questions right up front, and then I'll go through what my background is and the areas that I'm influencing today. So yes, product development is utmost important for all of us, right? And at the same time, how can we improve it? Well, we can improve it by really leveraging new technologies and then creating new products with the new technologies. I'm involved with the area of mobile environment, where applications for your smartphones is a key to drive just about anything that you do. Your smartphones are kind of like your agents. That also gets related to energy savings, you know, like we heard in the previous speaker. But that goes even farther, because there's a huge momentum today on the smart grid. How many of you have heard about the smart grid? How many of you are using the smart grid at home? So that's going to be the next stage, right? It's how do we control energy at home? How do we send information back and forth to the utilities, and then do something with that information in order to avoid the high peaks in energy. At the same time, I'm also involved in the healthcare, the areas where the population is getting younger, but at the same time, there's a lot of things that we're going through in order to improve the sense of aging, if you may. So one of the things that I'm working with is on remote patient monitoring, which is kind of like a new product in order to understand the biometric signs of individuals and to be able to provide information back to their doctors or to their case managers, so that they can be, a problem or an issue could be highlighted before it becomes a crisis. So that's a new product that will facilitate more jobs, as well as increase the livelihood of the population.
Okay, I'm actually going to move to the second question here that we have. In your opinions, is there an entity or organization that provides a strong template for successful productivity in manufacturing?
Since I worked for industry over 20 years and I started the chemical industry, I'd like to give one example from chemical industry. It's Dow Chemical's Freeport, Texas facility. This is almost like a chemical city. I don't know if you've heard about it. They have 75 production plants in the same area. They have 5,000 acre area. And each facility or each plant produces different chemicals. And some of the chemicals can be used as a raw material for another plant, so that their shipping costs are drastically reduced. And so they also look at the cost effectiveness. If it's not cost effective, they will not produce, they will buy it. So that's their philosophy. So that's one template that it has worked for many years. It's been working real well. They have $13 billion assets and $27 billion sales volume, so it's working. That's one template. In energy area and for our state, I can talk about several models that will increase the utilization of solar photovoltaics, and in return, that as a result of that it will increase the productivity. And so those models can be used as a template. And one of them is that feed and tear that was implemented by GRU in Gainesville, Florida. It's a model that was developed in Germany. And they initiated and they are sold out for 3 years, and they have a cap of 4 megawatt of solar panels. These are rooftop solar panels, and so they're already sold out. And the second model is the utility invested photovoltaic systems, and in our state, Florida Power Light, they have actually installed 110 megawatt of solar, and 10 megawatt at Kennedy Space Center, and 25 at DeSoto, and the 75 is actually a solar thermal facility in Martin County. And the third model is, again, solar thermal area. It's in Harmony, Florida. This is in collaboration with FSU and Florida State University. It's a solar thermal facility being constructed. Thank you.
Thank you very much. I'm going to move to our third question here. Have you seen key process improvements being emphasized in your sector that will improve GDP? Are such efforts perceived as being important to your sector currently?
Rockwell Collins has been around for a long time, and we've always kind of did a tail end with the way that the FAA was followed. We're governed by rules, and so we follow a process, very logical in the way we do things. But one of the things that we've been noticing recently is the fact that we have an availability of new materials that allows us to be more efficient, allow us to improve the way we can design our products. So I would strongly say that some of our process improvements would be trying to figure out ways to get the product to the market as fast as possible. So streamline materials, streamline the way we're actually designing and engineering products, and figuring out ways to streamline the systems aspect of the job to cut back on the amount of time that we're doing. And so material processing and systems engineering and software designing is kind of where we're going.
That response. I have another question I'd like to move to. We know that manufacturing has an effect on productivity. How has the current socioeconomic status within our state had an effect on manufacturing and decisions that are made in manufacturing right now in your sectors?
I think there are certainly challenges with the current situation in the state of Florida. As you indicated on some of your slides, the percent of employment related to manufacturing is declining in the country, and Florida is about half the national average. So that sort of ripples through into what I kind of refer to as the soft infrastructure, and that's both on the side of education as well as just the whole supply chain support. When you're trying to manufacture in an area that does not have a lot of manufacturing history, the whole 24/7 availability of support is oftentimes not there. And clearly this is something that the state needs to work on, and it's particularly, I think, critical in the healthcare industry. When we look at our industry, most of our companies get at least half of their sales from products that have been introduced in the last 3 years or less. So you've got a constant churn of new products, and we compete on a global level, so we can't just look at how we stand versus other entities of the state. We have to look at how we stand versus other entities of the world. And when one looks at the fact that the government is the major funder of healthcare, whether we have a private system or not, certainly the amount of regulation has a major impact on the speed at which products can get introduced. And it has a major impact on companies thinking about whether they're going to do the development and manufacturing in the United States or whether they're going to go outside the United States. Historically, the U.S. through their FDA approval process was the gold standard globally, but now the European system using ISO standards is rapidly becoming accepted around the globe. And if a company can do the development in Europe in half the time and at half the cost, that starts to get real attractive in a hurry. When you find out it's recognized around the globe, that has a major impact in decisions. And we've probably in the last 6 months seen more questions and fielded more questions about firms who are interested in whether we would do something domestically or internationally than we have in the previous 15 years of our existence. So I think that's clearly going to have a major impact on the state.
Okay. Thank you very much. What I'd like to do now is we've talked a little bit about things from an economic perspective. I'd like to talk about things now from an education perspective and how STEM education affects the problems that we're talking about right now, and STEM opportunities. Well, as far as job opportunities in the STEM area, this information from the Bureau of Labor Statistics shows that the estimated 2004 employment opportunities in all STEM occupations was approximately 145 million jobs. in 2004. This number increased to approximately, or is estimated to increase to approximately 164 million jobs in 2014, a few years from now, for an increase of approximately 13%. So that's one metric I'd like to discuss. Now, as far as occupations that have been identified from this same Bureau of Labor Statistics Workforce Data Project report, some of the areas that are seen with the highest number of added jobs are computer specialists, computer and information systems managers, engineering technicians, life science people, and civil engineering are some of those areas that are seen with some of the largest job growth in numbers. Now, as far as the highest rates of growth in percentage, some of those areas are forensic science, medical scientists and epidemiologists, biomedical engineering, computer specialists again, and environmental engineers. So with that being said, I'd like to show one other area which I think is very important to STEM. How do students learn in STEM? Basically, there is a paper, I pulled some information from a journal paper written at Morgan State University that talks about some of the fundamentals generated by coal in engineering education. And there are 4 different areas that engineering students are broken into. The primary one is assimilator, and that is a dominant learning ability, abstract conceptualization, and reflective observation. Converger, dominant learning abilities are abstract conceptualization and active experimentation. Diverger, being third, they're best at concrete experience and reflective observation. Their greatest strength lies in imaginative ability. And accommodator, their dominant learning abilities are concrete experience and active experimentation. This is how engineering technology students learn, and this has been documented. So that being the case, I'd like to open some questions up to our panel. That has to do with STEM opportunities and STEM education. In your opinion, how can we improve the current status of STEM education in Florida? What are some of the areas that we do not do well in? What are some of the areas that we do well in?
Since I'm with the university system, I would like to speak for higher education. I think the biggest issue with STEM education is the retention rate during freshman and second year. The retention rate is 50%. It's very low. So our goal is to increase that. So we need to understand why the retention rate is that low, and then address those issues. And so I've been talking to, this is my personal interest, I've been talking to some of the engineering students, new students, and my son being freshman engineering. The biggest complaint was, especially for social students, for example, that they say engineering too much science, that we are lacking the social sciences, so they're missing that social element. So this is just one feedback. And in the STEM education area, there are a number of programs within the consortium universities. One example, at University of Florida, there is an IQ program, and this is Innovation Through Institutional Integration. This is an NSF-funded program, 5-year program. And it fosters integration of NSF-funded research and STEM education, economics, behavior disciplines. And it involves the students, the faculty members, administrators, so it's a very good program. And another one is about to be launched by the University of Central Florida. This is for pre-college students, and this is being established through their business incubation program and in collaboration with the industry within the region. And so they are including the industry. I think that's a very good thing, because it's really important to get the input from the industry, to include them, to create internship opportunities for our kids at an early age, maybe during high school years, so they may have an interest in science through that. And other consortium universities either have some STEM programs or about to include. Other programs that we do well, I think, almost in each university they have engineering summer camps. That's very useful, introducing high school kids to the engineering programs. And so.
Okay, Mr. Boris, I think you had a response too.
Yeah, I just want to add that, in fact, I believe that you have to get into their interest at the high school level. So I have been involved in several programs, one of them called idea of technology where you essentially go to the high schools and you train them on what engineering and science is all about. And you would be really fascinated by their interest and their learning, because many in the 9th grade to the 12th, that's the area that they really get hooked on science. We have looked at the number of students that have proceeded from high school to college, and that has been they have had a much larger number of students going to college because of that program that has been in place for the last probably 10 years. The other thing that we're doing essentially is also bringing to the high schools application programming for cell phones, for example. FAU has a program which was sponsored by the NSF to bring that knowledge to high school, to have the students actually become familiar with writing and programming on the Android language, the Google Android language. We had that experience this summer, and it was very rewarding because you could see the students how they could essentially do something that they would be proud of by programming the phone. And after having this was a 3 to 6 week session, they essentially would come back and they would want to learn more and signing up into programs at FAU. So I think it's really getting into the early years at high school in order to be able to get them hooked into the material.
Okay, thank you.
Our company, we actually have a program where we start at the high school level, and we actually bring them in as like an internship during the summertime, so that they can sit with engineers and learn about the different types of areas of engineering and be able to get a feel for what their mathematics class is all about, or what their science class is all about, so that we can get them at an early age to start getting them involved with the engineering. I don't know if a lot of people know, but RF technology is out there, but there's not many people that actually end up stemming a little bit of education based on that. So engineers are dying away from getting that expertise, and we're having a problem finding those types of employees. So we have to start at the high school level in order to get them ramped up in engineering and try to get them at an early age.
Thank you, Mr. Henry.
I was just going to say, and I'm probably risk creating a hostile audience here, but don't let academics get in the way of their education. And I'm just looking at a study that was recently published where they polled a bunch of 13 to 17-year-old students, and over 52% said they had little interest in manufacturing or engineering. Less than a quarter had been exposed to anything that would position them in a place to make that decision. And the gist of it is they said they need to bring tinkering back. And if you need an academic reference for that, there's a book called Shop Class's Soulcraft that was written by a person who's a PhD and was a member of a think tank and all that, and now repairs motorcycles for a living. And goes through in a much more elegant way than I'll ever do it, but talks about how we have developed technology and all the things that we buy and consume that basically we take it to where it makes us the dumbest part of the whole thing. It used to be if you drove a car, you had to know how it worked because you might have to get out alongside the road and fix it. Now, cars are being made so that even if you're a stupid driver, they keep you from getting in an accident. And no one knows how they work. I think it's just real key that we get early involvement of these students and that they can actually get their hands on things. I know when I look at chemistry courses now, they're doing all their experiments simulated on a computer. When I took it, you cut your hand when you broke the glass and you burned your hand with chemicals and you learned what you could and couldn't do. And now when I see some of these people who've never been exposed to those things and they're designing facilities, I get scared to death. I wonder whether or not they know what they can't do. And I don't know if I want to walk through that factory that's been designed by someone who's never, burned their hands or whatever. So I think that, the practical side of this, has to be brought in, at a young age to get these people interested, to get them thinking, and then they can use the academic side as a tool. That's the tools to being able to advance, but you have to generate that interest first.
Okay, thank you for that response. What I'd like to do is move to the last area, and I'm going to ask one question, take one response, then I'm going to open the floor for questions. So the last area that we want to discuss is product development. And basically I want to talk about this term lead user. And in a nutshell, what is a lead user? A lead user is someone that has an idea or has a need for something and they develop it for themselves, but there happens to be a market need for it. One of the best examples I've stumbled on in my lifetime is coaching basketball. I coached a kid in California that created a hands-on basketball that has the little hands painted on it. He couldn't shoot. He developed it for himself. He sold it to not a medical device company, sold it to a sporting goods company, and now pays his cousins way through college, basically, and his whole family. That's, in a nutshell, what this definition is. Product development, basically the steps of that from a lead user standpoint, starting the lead user process, identifying a customer need, identifying lead users, and developing a concept. In a nutshell, this is what it is. My question to the panel is, with product development, can product development be incentivized, and where does it fit? Does it fit in industry? Does it fit in education? Is it a hybrid? Where does it fit?
I think it would kind of fit in both school, education, and in the industry. At my company, we call it critical thinking. That is where the student actually becomes very involved with being able to understand the concepts and apply those concepts to be able to give you a product. In industry, we all know a lot of people wear many hats. We do that today in any job, regardless of where we are. And one of the key things there is being able to understand what the whole picture is to get, being able to understand what the output is going to be in order to figure out where you should begin. And so for me, in my industry, critical thinking is exactly that. And it starts at the high school, it starts right through college and right into the industry.
Okay, thank you. What I'd like to do now is take questions from the audience for any of the panelists. You can feel free to direct your questions directly to any of the panelists. Yes, sir?
I have a question for all of you. ATE is always driven to bring the new technician on board with new skills and new talents to meet new challenges. So I'd like each of you to tell me, and it's not as a aggressive thing, what should we, although Gary's smiling, what should we take out of the current technical curriculum to make room for anything that has to come into the curriculum tomorrow? From your perspective in your sector, what's a skill that has either already been automated or not an issue or is already incorporated in something else? We have to take something out if we're going to put something in, basically.
Well, I think you have to have, in my mind, you have to have the basics in there and the kind of troubleshooting knowledge, that whole logical thinking process and how you can make something that's not working right work right. That whole power of observation. Now, exactly what you take out, that's a little harder for me to say. But, certainly at the engineering level, we see starting engineers, who will come in with a perfect 4.0 average or whatever, and they'll take a little project and spend a week on some advanced computer CAD and design system when, us old guys would draw in 15 minutes on the back of a paper towel. And, some of that's all that overthinking or overutilization of some of the latest tools, as opposed to understanding how things really work at the, at the factory floor level. When the machine breaks, I don't need somebody who could design a new machine and give me 36 pages of theory. I need somebody who can get a meter out and troubleshoot it and tell me, which part needs to be replaced or what needs to be hooked back up. And, I don't know if that helps, but I mean, that I think is some of the hardest skills to find at the technician level. Is getting somebody who's comfortable around machinery and who has that troubleshooting capability, that logical thinking capability.
I think it's really keeping in tune with the latest technology. As those technologies come on, you have to be ready to be able to teach those technologies so that when they get in the field, they're ready for them. Like a lot of the new programming languages, a lot of the new things that you can see in the horizon, many times they come out of school and they're not ready for those. So I think that anticipating those trends and then providing those trends to the students will be helpful.
My recommendation is the same as Mr. Boras. Teaching, I don't know what to take out of that. I'm not very familiar with the curriculum, but what to include is emerging technologies and like, for example, teach them what is coming in the pipeline, like smart grids, photovoltaics, renewable energy, and if they're interested, they can go deeper on their own, or they can look for other courses, classes. There will be a lot of online, courses available through the consortium pretty soon, within a year or so. And so that would be my recommendation, including new emerging technologies, so that they are aware what will be available in future, in near future, and far future.
I would like to see more what I like to call the doers of my company. I can hand somebody a task and they can fulfill that task without too much guidance. So I look at it this way: a lot of what we're teaching today, we're teaching a foundation. So if we could take that foundation and give them the tools to be able to apply that foundation, then there really is maybe no need to take something out or be able to add more to it. I think that at this point, the new technologies that are out there, there will be students that will actually go off and take another class, or they're gonna try and find ways to maybe take an extra course to do that. But for me to add to or take away, I think it's more of the building blocks of the foundation. I'm a little bit more old school. So yeah, I do want the technician that knows how to pull a wrench and get a DMM and be able to look at the spectroanalysis if I need them to. That's my thoughts on it.
If I may add, I think that you should have a goal to put online a new course or 2 or 3 new courses depending on the technology, but at the same time, those courses that you have been offering for a while, perhaps they can be self-taught or online so that they can actually grab that knowledge, and there will probably be a lot of other folks that could help them if they run into problems, but then keep the instructors focusing on the emerging technologies.
My question to the panelists is regarding STEM education. What can be done to increase enrollment of young students in basic sciences and engineering? Do we provide them with paid summer internship? Do we provide them with scholarship? And countries, developing countries like Brazil and Western Europe and many other countries, education is free. We are loading our students with loans. Can something be done to lessen the load of students in terms of loan repayment and provide more scholarships and paid internships? Thank you.
Would you like to take that?
And also one more thing, and to influence our guidance counselors in high school not to turn away the female students from entering science. So tell them, become a secretary, become a nurse. You don't have to like math. It's okay to hate math. Such words should be eliminated from the dictionary of guidance counselors.
So My wife is a guidance counselor in high school. So she's got my picture and my bio right on her bureau. And she essentially gives my story to all of the students, because I have gone through a lot of phases in my life, and she promotes engineering and science continuously. So I can talk through that particular one. I think that providing scholarships, I think that piquing their interest in science and technology is the key, right? Because if you've got the interest, then you go and you figure out even how to get a scholarship, right? Because you're self-driven. I think one of the most recent examples that I have seen is really the robotics competitions that really provide the students with a task for, I think is in the neighborhood of about 6 weeks or so, and they go into it without knowing anything, and they come out of it with a lot of expertise. I mean, we have worked together with the students and the high schools, and many of those students continue in the science and engineering. So I think those two things will be helpful.
I'm going to take one other question. I'd like to, sir, for you to have a chance to answer your question.
Entrepreneurship in academia will help manufacturing, if that is true, or how much emphasis should be given?
His statement was, we have entrepreneurship and we have education. How do we merge those together? Where do they fit together, and how do they fit together?
Yeah, I think entrepreneurship is all about doing things that haven't been done before and being able to make money out of it, if you may, or be able to get products developed in such a way that they were not done before, with less cost. All of that is really protected by patents, if you may, right? And that's a way to really incentivize the students or the engineers. So I think in combination of those two, that's one way. Entrepreneurship is really it's like an art, right? You really develop it by trying out things and making things happen that didn't exist before.
What should we do to increase the graduation rate in science education? I can give you just one simple example, that in this country there are 762 universities and colleges have BS in physics program, for example. And the graduation rate is very, very alarming. 70% of those institutions graduate students between 0 to 4 per year. The next, from 71 to almost 89%, the other institutions graduate students between 5 to 9. And there are only 10% institutions who graduate 10 and above students in the physics program. So where is the problem? What should we do to improve the graduation rate? Should we close all the universities who graduate students between 0 to 4? That's basically what the situation we are facing in big universities who cannot graduate more than 4 or 5 or 6 students.
Okay, the question is graduation rates. How do we have an effect on that? Who'd like to take that?
I can go. I mean, I think you have to make it fun. I mean, I have a BS in physics myself, and I had a lot of fun while I was doing it. But at the same time, I was doing my double E degree because I knew that there would be more jobs in electrical engineering. So I think it was fun doing it, but then looking forward, I kind of combined the two degrees in order to come up with that. So to me, it's really the interest of the student and making it, allowing them to actually grow and making it fun for them.
Anybody else?
Yeah, I guess I would also ask the question, why are they in the program in the first place? Are they being channeled into some of these departments because those departments are aggressive at recruiting students to meet their need for the number of full-time students or whatever? Or are these students who, are really interested in that particular aspect of education? And I mean, I think that's critical. I mean, there has to be some reason why they're choosing not to finish that degree. And I don't know how many of those students who do something else or either transfer out to another department or just drop out. I don't know how many of those are being, queried in exit interviews and things to find out why they're leaving. But, it just seems to me that at the time they're going into those programs, I would hope they have a good understanding of what the program is and why they're there and what they want to get out of it. And if it's just if it's a mismatch at the beginning, I guess that's one issue. If it's, if the programs aren't fulfilling, fun and educational and fulfilling in that sense, or they get there and realize that when they're done, if they don't want to remain in academics, there's not a whole lot for them to do in the industry. They can't draw that tie between that program and a future career. I mean, it's without knowing why they're leaving, it's a little hard to answer. But the question would be, why are they there in the first place if there's that much of a dropout?
Well, thank you very much for that response. I'd like to give our panelists a hand. And I'd like to give you all a hand too. I think everyone here is very passionate about the opportunities that we have to make education better and to make things better in our communities. And I'd like to close just with the same idea that I opened with, is we're all concerned about success here. The success of our students, the success of our communities, the success of our programs. How do we merge the opportunities with the preparation? And that's what I'd like people to think about, that when we go back to our different organizations, how do we merge the preparation of our students with the opportunities for our students? And if we can do that, then they'll be successful. Thank you.